So as I was saying before, we have these three noises. They're layered together. This all goes to the displacement, where right now we have a scale of 0.015. Now, one thing to also do, and a lot of people forget about this, is that you want to allow displacement to cut into the object. With displacement, what ends up happening is this: a value of 0 means that it's not going to change the location of the geometry, right? So when this goes to displace, the geometry starts at 0, and then any positive values will push that geometry outwards. Well, we also want to tell the geometry that it's allowed to go into the mesh so that it can displace negatively as well. And in order to do that, we need to change the range of values from 0 to 1 to -1 to 1. So let's say color change range. Again, this is just like a fit function. And we'll set this before the displacement right here. So that we'll say the old range is 0 to 1. Now we want this to live at -1 to 1. And if we do that, let's go ahead and see what that gives us. Okay, and there you have it. That's a massive difference. This and this. See? That's a huge difference. So just be sure that you do that whenever you're displacing things. That's true for characters. It's true for anything that you do. If you're building out a displacement signal, you want that going from -1 to 1. Okay, so now that we have this, and we'll just turn down the scale a little bit here too. But now that we pretty much have that base for the flagstone, we now need to make those rectangular shapes. So in order to do that, let's go ahead and pause the render and make a new noise. Max on noise, plug that in. Let's also disconnect displacement and go back and turn off all this stuff so that we can render things really quickly. Okay, we have a noise. Let's start off with a cell noise. And right away we get something like this, which, as you can tell, needs a lot of work. This is a really square shape. We can do things to stretch this out. So in the scale, in the X direction, we could say maybe 4, and in the Z direction, we can also say 4. So that now we have these stripes, and then we can turn down the scale, so we could say maybe 0.25, and that's going to be a whole lot better. So we'll start there. It's a good place to, start this all out, but it's still not correct. We need to have these stones overlapping each other in a way that's not perfectly symmetrical. So visually speaking, what that means is I don't want these lines going perfectly straight. I mean, that the line I just drew is not straight, but you know what I mean. We don't want this line right here going down. So we have this thing in the input here that's allowing us to offset these cells. And one way we can do that is we can make a copy of this noise, and let's actually make an identical copy. So right mouse, we'll say actions, create reference copy, and we can go ahead and plug this guy in, and we can really stretch out the scale in X and Z so that we have these perfect lines that just go straight across. So check this out. Let's go ahead and delete this channel. If I scale this to something really big, like 300 and 300, now we have something like that, and we can use this information to adjust each one of these rows in a way that lines up with all of the tiles that we have right here. So if I just go ahead and plug this into the coordinate offset, we get something like this. And that's not quite right, but it's going in the right direction. All we need to do is we now need to tell this noise right here to not adjust this in the Y direction. This signal here is a vector signal. Again, it's X, Y, Z. It's 3 pieces of data. And that's offsetting the X, Y, and Z coordinates. So all I'm saying here is I don't want to go in the Y. And it's very easy to get rid of that. All you need to do is say vectors to scalars. That turns our vector signal into 3 float signals like that. And then all we need to do is use this vector maker right here. That's what they call it. So now we have X, that'll go right here, Z, and instead of using the Y, let's just set this to a value of 1. So if that goes to the offset, now we've successfully altered the location of all these tiles, and that's exactly what we want. Now I'm pretty sure that if we want a different seed that we can do that. So let's say delete this channel. Yeah, so we can do stuff like this and it still lines up just fine. Okay, so that totally works. Now, we have this, and let's say that we want to blend that in with what we have going on down here. Let's go ahead and make a RS color layer. And all we need to do now, this happens before the range. We want to convert our values negative at the very end right here, and then feed that to the displacement, right? We'll go use this as a base layer, and then all these tiles can now be layer 1. And we can just, let's say, multiply. So that cuts into the values. This can then go to displacements. And actually, before we do that, let's just check out this signal. So we'll just go right there to surface, and we end up with something like that. Let's go ahead and turn down that multiply, and let's try something maybe right around here with that. We'll go a little bit more, right about there. Okay, so now that we have that, I'm going to save just in case. Displacements. Let's bring back our generic shader real quick. Plug that in. Go back to the object level. And tessellation, displacement. Let's see what that does. All right, there you go. Now you can see that we're starting to get somewhere with this. We do have some issues with the tessellation though. Look at that. See how these bricks are having a hard time subdividing? Well, you can fix that by going up here, and we can change this minimum edge length to something else. Instead of 4, we could say something like 2. But the problem is that it's going to be very heavy on the render engine to do this, right? It's still thinking about building up all these polygons. It's still subdividing right now as we're talking. So it's really not the best way of doing it. It takes a massive hit on your render times. And well, unfortunately, that's just kind of how it is when it comes to this sort of subdivision here. Okay, now it finally subdivided everything properly, and we have something like this. So it's still a little bit jagged right there. Once there's depth of field, it won't be noticeable, but I just want to show you that because, as you can see, it's just, it's just kind of how this is happening right now. So we have that going on. It's pretty cool, but also it would be nice to alter the offsets along some of these noise patterns here, because look at that. We have these noise patterns along the different flagstone bricks, right? But they're all kind of overlapping. So see how we have one big shape right here? We don't want that. We want it to change for every single brick. So we can do that by taking the original noise, which again looks like this. We can take this guy and we can use that as an offset to each one of these noises down here. So the offsets, let's go like that. And we'll do that for all 3 of them, like so. Let's scoot this over. And now, once we do that, we can then go to this guy, and we have something like that. Now, this still isn't perfect because we could see some of these shapes do kind of overlap each other like this. So what we could also do is we can try affecting the scale. So if we go to the scale now, and we plug that in, It's going to be too much at first, but you'll notice a pretty substantial difference. Right about there. And so some of these noises now are really, really small like that. And that's exactly how we're going to break this up a lot more. It's a little bit too small though, so we need to change that range. So color, change range, and we're going to take our scale, plug that in for each one of them. So we'll go like that. And all I'm trying to say is that I don't want it to scale down too much. So I'll go right there, and then instead of allowing this to go down to 0, I'll say 0.5. 0.5 is the smallest scale that it's allowed to be, and that will really help each brick stand out like that. Okay, great. So now we have that. Let's plug this into a displacement, and we'll see what that looks like. And as you can see, this is now looking much, much better. In the next video, let's continue on.